Right, so should be live. Let's see where we are now. Should be live. Yeah, seems that way. We're live. Oh, hi. Yeah, DJ Roll keeping it cool once again. You know what I'm saying? So we're back this week with another lesson in measurements. Now, this time, as you can see on the screen, we'll be focusing on measurement errors, right? So that's the focus today. All right. Now, as you can see, there there is some information. Let's zoom in, see if we can get a close up on it. Um, there are different types of errors in measurements, right? So we have these terms here: gross error, systematic error, absolute error, relative error, error. Well, we have accuracy, precision, resolution, and significant figures, as well as measurement error combination basics. Okay, so these now, guys, are the different categories of errors. But from last week, you would have learned about significant figures. I'm going to underline the significant figures part here. And what this is saying is that crucial to understanding errors, significant figures must be understood. So let's underline our significant figures, because significant figures, if we remember from previous lessons, all right, especially this was the last thing we did uh, before. And as you can see here, uh, the number of significant figures indicates the precision of the instrument. All right, pay attention to this line here. The number of significant figures, and let's highlight that part from a previous class, where it says a number of significant figures indicates the precision of the instrument. All of this is crucial. So, all right, so this is what we're gonna look at today. All right, now if at this point you have any questions, what you could do is just text your questions in the chat, and or you could log on to the Zoom link, which I'll be sending in the group or in the Google Classroom for this class. All right, so let's find that class and place the link there. All right, and while that's taking place now, um, I just want to ask you this then. Well, it's not quite. It's taking a while to load. Oh, there it is. Okay, so let's create the link and we're gonna send it here. This is form 3, and it's actually a link. I think it's a link. It's a link. Let's place a link there. See if they can join it. All right, so that's the link. And of course, they could join the Zoom class as well. And the Zoom link will be sent as well. All right. And as soon as we get that going, we'll let you guys. Yeah, that's it. Good. All right. Now, all right. So this is for 13AB. All right. There we are. So we're live. All right. So there you go. Significant figures have a lot to do with the errors. Now, remember, significant figures refer to any digit that's not zero. Now, there are times when zeros are significant, and those were discussed in previous lessons. All right. And if we were to uh, go back to previous lessons, we know that, well, the significant figures follow some rules. And as you can see on the screen here, uh, significant figures, uh, zero can be used for cosmetic purposes in front of a number. And in that case, it's not significant. And also, zeros to use to locate the decimal point. Now, Zeros, in this case, zeros in front of a number are never significant. That's pretty much a rule they're trying to cement here, as you can see in the screen. But then, other than that, zeros between significant figures are significant. Zeros that are trailing once there's a decimal point, they are also significant. So that's a rule. But in this bit of information here, the significant figure indicates the precision of the instrument. Now, forget about what comes after this. Wiper, no say, but this part is important. The number of significant figures indicates the precision of the instrument or the measurement rather. Yeah, let's talk some more about that. There are different instruments we can use to measure um objects. Now, I want to bring your attention to something here. Suppose you are asked to identify the length of this bar in centimeters. What would your answer be? All right, that's my question to you guys. Um, the bar is the red bar we're talking about here. What is the length of it? Remember now we're taking a measurement and we want to be able to write it in the correct way. Might sound simple, but there are some limitations of the instrument. Um, like for example, how accurate is the answer that you will give me? Now, check this out, guys. The accuracy of a measurement is how close the measurement is to the true value. This is restricted by, sorry, this is restricted or limited by the accuracy of the measuring instrument. All right. The ruler is marked in centimeters, so any length measured with it can only be given to the nearest centimeter. And so this is what we're learning about. With measurements, there are scales. All right. Measurements have divisions, really. So measurements give you a scale. Measurements are done in a scale. Scale is a standard. So again, just like how you take a scale to measure the weight of something, okay, fine. The weight is given in some units, and the units on most scales usually pounds, or in some cases kilograms. And so, but understand that every instrument has its limitations, right? And so limitations of the instrument will affect the accuracy of the measurement you're given. Now, this is an activity that you guys gonna do for me um, at the end of the class. All right. So, all right. So now, crucial to that, we're focusing on arrows and errors, but before we can go into details with errors, we have to understand um, what causes an error, right? And long story short, when there's the absence of accuracy, then we call it an error. So in other words, if you ask me, if you ask me any question and you already have the answer written down, but you want to see if I know it, what's gonna happen is that when I answer you, you're gonna look back on the answer that you have and see if it's the same thing. And if it is the same thing, you'll say, "Oh, I'm accurate, therefore I'm correct." But if I miss out a word or something that you have in your answer, then you would say not completely correct, and that I would have made an error in my answer. I would have made a mistake in answering. Now, the thing about this is that errors in physics are not mistakes. All right. Errors mean, all right, basically lack of accuracy. All right. Um, and of course, precision. Let's just say it's put precision. And so it's lack of precision. And that will give you an error. No. So accuracy here. Accuracy has a definition. It's different from precision. So the objective for today is to be able to tell the difference between accuracy and precision. What we're seeing here, the degree of closeness to a true value is an accuracy. All right. And of course, precision is the degree to which an instrument or process will repeat the same value. So again, what is the true value of your weight? If you go on a scale, that is considered the true value. However, if you go to the doctor and you take your measurement, he's gonna write the value that he sees in his file on you. So therefore, if anything should happen to you, they're not gonna use your weight that you took at home in the bathroom. No, they're gonna use the weight that he recorded in the doctor's office, and that's on your file. That is considered the true value. And so any value that you take after that is basically compared to that true value. So it could be more, it could be less, it could be the same. If it's the same, it's 100% accurate. All right. If it's different, then uh, it's there's some degree of error. And some books will call it uncertainty. Certainly, that's the way they address that situation. All right. So if you have any questions, guys, just ask them in the group, in the chat, in the classroom, wherever. All right. So that is our approach here. Accuracy is the degree of closeness to the true value. Precision is the ability of the instrument to repeat. Now, again, repeating the measurement is a way to see if the instrument is working correctly. And what happens from time to time, okay, the instrument may not behave the same way as it did the first time. Now, if it's a new instrument or a well-made one, then it should hold up for time over time. But if not, then it's gonna lose accuracy. It's gonna also lose precision. Uh, that's amazing. All right, now they have some other information here in this chart comparison here. Measurements, what affects accuracy is single factor or measurement, whereas precision is affected by multiple measurements, and um, and that's the thing. So it's a one-off. Accuracy is a one-off thing. Ask you how much, you tell me, bam, is it correct? Yes or no? That will move on. That's accuracy. All right. And then precision now is like, for example, I ask you like 5 times the same question, and if you give me different answers each time, it means that you're not precise. Maybe one of those answers are correct, but the fact that you're changing the answer each time, telling me that you're not precise, you know. So that's the same thing. All right. So again, we see that where this is actually used in physics and in chemistry and engineering, statistics, and so on. All right. Hope this helps, guys. We'll go on to a more demonstration here. So it's actually a more visual demonstration, I should say here. Now, if you notice here, this is a dartboard. And as you can see, there is that precision factor here. All right, low accuracy, low precision. Why is this first one low in both? All right, so we have to ask yourself this. The person threw 3 times at this board, and those three attempts, the dart ended up at different locations. And so because of that, the person who threw it is not precise in their aim. And also the person on one of those 3 occasions did not hit the target. So on those occasions, they miss the target entirely, therefore they have no accuracy. But then with the 3 attempts going in 3 different places, they also lack the precision. So a person like this, if this was a tournament, this was like an athlete, no, you would have to train them. This person would lack training. All right. And so that's how you deal with this. All right, guys, remember this is accuracy versus precision. All right. And this is all related to measurements, right? This is all related to measurement. And measurement, again, is all about comparing the instrument reading with a known value, all right, with something that's already known or documented somewhere else. Because remember, guys, with measurements, many of the times you're not the first person to take the measurement of a particular thing. And because of that, then, you know, some measurements taken before you have done yours would be considered more accurate because it's documented. and by the persons who document them, they believe them more than you. So that's how it works. All right. So then here's our measurement. This is our measurement, and of course, let's call this part two. All right. So then let's look at this second situation. The second situation is the same. Another person rather throws the three same darts, but this time they would hit pretty much the same place with the three, but again, not hitting the target, and so they would lack accuracy. Therefore, the accuracy is low. All right. The aim of this is for them to hit the middle, that red spot there. All right. Guys, have any questions or comments? Send them in the chat there. All right. So the other situation now is, or rather, the third situation is where you have a high accuracy and a low precision. High accuracy now means, in this case, that another person would have thrown the three same darts, but this time hit the red spot all three times. However, it's three different locations on it. So therefore, they would be accurate, definitely high accuracy there, low precision because, well, the other darts didn't, line up with the first one. And then an example of high accuracy and high precision now is when the three attempts were made and all three attempts hit the middle of the dartboard. So that would cover the accuracy factor and as well as the precision factor. This person is both accurate and precise. All right. So that's the idea here. All right, guys. Now, yeah, guys, have any questions? As I say, you can always send them in the chat and we move on. All right. So accurate here means correct, precise mean consistent. And yeah, that's how it works here, folks. Uh one of the activities that you will practice throughout this um topic really is the measuring the different things, and the measuring the length really of different objects and writing them down in the right way. Now here are the instructions here. When you're measuring the length of something, right? They say read the instrument to every place that it can be read. Example, lines on the ruler. Length of the box would be 8.6. All right, so this item here would be 8.6 rather. And if we zoom in closely, we see that it is 8.6. Here is a zero. And then, of course, here will be 8.6 when you line it up here. All right, again, any questions or comments, send them in the chat. All right, estimate. So then estimate one or more digit can be, all right. So estimate one or more digit. Now, interestingly, this is 8.6, but this is exactly 8.6. If it's between 8.6 and 8.7, uh, then that's crucial. That's something that we need. Maybe a ruler wouldn't be able to tell us that, and now we'll start looking at other instruments used to measure length to different degrees of accuracy. All right. Now I believe I have information on that. But let's start here. This is or should be 8.6 from the ruler. All right. What this is saying is that it could be more or less than 8.6, could be more accurate. 8.67, if you were able to find that out, would be more accurate than 8.6, certainly. Because one, you have more decimal places, or we could say more significant figures. All right. So add units together. Definitely adding the units together. And so and then and let's look at this. Overall, the accuracy is getting the correct value of 8.6. Precision is estimating the last digit. Um this is crucial. Definitely crucial. Again, we're gonna apply what we learned to these examples here. And we will continue. This would be your assignment. Limits of accuracy. No, we want to look here at measuring length, and we see the different devices that we can use to measure length. In fact, let's get close up with these, and as a matter of fact, let's get that out of the way, and I want to show you this. All right, okay, and just go. That's just right, so we have different models here to show you. Just duplicate that for me. Yeah. All right, there we go. So there we go. We've seen some ancient ones and modern ones. I want you to have a look at this. All right, so the modern instruments for measuring length. Okay, that's important here. Ruler, most common. Measuring tape and screw gauge, vernier caliper. These are instruments that you guys are going to have to learn to use maybe soon, based on restrictions in this pandemic. We're not sure how soon that is, however. All right. So then these are instruments for measuring length. But guys, we'll talk more about this next week. Uh as we go on to the activity here. What I want you guys to do is to measure, to practice using the ruler. Tell me the length of this bar. And of course, all of these would be assessed here. All right, guys. So this is DJ Raul keeping it cool once again. And it was good to have you here today. I hope you learned something. All right. So peace. Enjoy the rest of your weekend and stay tuned. Remember to like, share, and subscribe to the channel if you want more information. And yeah, and guys, have yourselves a wonderful